Coordinate bonds are like covalent bonds. And once formed, and once formed, cannot be distinguished from from a covalent bond, right? Secondly, coordinate bonds are formed between two atoms, one of which is electron rich and the other is electron deficient. And the other is electron deficient. Okay? So one of which is electron rich and the other is electron deficient. Third, third, the electron rich element or electron rich atom is called as a donor, is called as a donor atom and acquires positive charge and acquires positive charge.
So you're saying that
Yeah,
you can make a salt and the salt will be in coordinate bonds, not ionic bonds.
yes, yes. Okay, so
Like
and
rubidium chloride.
hmm, this okay, and the electron deficient atom or element is called electron acceptor atom, is called electron acceptor atom. Okay, the coordinate
Yes.
bonds are also called as dative bonds. The coordinate bonds are also called as dative bonds or or semi-ionic bonds. Semi-ionic bonds. The dative bonds are also called as the coordinate bonds are also called as dative bonds and semi-ionic bonds. Okay, and only elements from atomic number 1 to 10 can form dative bonds.
So
This
both of them have to be between 1 and 10.
exactly.
Even the poor one and the rich one have to both be between 1 and 10.
Yes. The dative bond or the coordinate bond is basically a concept, where we say that, the atoms can't expand their octet. So they form coordinate bonds. The atoms can't expand their octet. So they form coordinate bonds. So they
So
form, sorry?
beryllium oxide,
No, 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 no. Listen to me.
hydrogen fluoride.
No, they are normal covalent bonds. I'm explaining it to you. Listen. So when we are talking about the coordinate bonds, what do we say? The atoms can't expand their octet, so they form the coordinate bonds. All right. Now, understand. What is happening here? Just see. So, for example, if I take an example of ammonium radical. Now, how is ammonium radical exactly formed? We have ammonia, N has atomic number 7, configuration is 2, 5. So, you will have 1, 2, 3, 4, 5. Yes or no, Mark?
Yes.
And we have hydrogen. So hydrogen shall have this. So we
Also,
have,
that weird lone pair
and there's a
will
lone pair.
be
Yes, yes, yes. So
so
this
the
is the
lone pair
structure.
bond is a coordinate bond.
Yeah. So this is ammonia structure.
A hydrogen bond.
No, no. This is ammonia. Now, ammonia is basically this kind of structure where nitrogen in the ammonia, this nitrogen atom has a lone pair. Because it has a lone pair, what exactly is happening? We have H plus, because H plus, let's suppose some acid HCl, so that HCl basically it breaks into giving me H plus and Cl negative. Because H plus and Cl negative, why is it formed? You understand there are two electrons involved here, isn't it?
Yes.
So the bond basically breaks from here because chlorine is more electronegative. So both the electrons are pulled towards chlorine, so it acquires -1 charge and H becomes H plus. You understand? So we have
Yes.
HCl. We have HCl. So what exactly does this mean? You tell me that H plus, if it is,
Also, this hydrogen H plus is taking both of the electrons from the lone pair
yes, yes.
and sharing them.
Hmm. So this is how this H plus comes and attacks the lone pair, right? So how does it attack now? Understand. Now what is H plus? You tell me the meaning of H plus. H
A
plus is
proton.
somebody, it was an atom, right? Whose
Yes.
nucleus had one proton and there was one electron. So that was neutral hydrogen atom. Neutral hydrogen atom. But if somebody has taken away the electrons of hydrogen, then it would become H plus. Are you understanding?
Yes.
So my point of telling you here is that H plus is that element, that ion, which is extremely deficient in electrons. It does not have any of its electrons. Do you understand?
Yes.
And because it does not have any of its electrons, so it comes here because it sees two electrons on the nitrogen. And now it is sitting right in front of nitrogen begging for electrons, that, please give me electrons. I want to become neutral. So what does nitrogen do? Nitrogen says, okay, you take this cross electron from me and let me give it to you. So thereby, nitrogen donates one of its electrons to hydrogen plus. So NH, H, H, these are normal covalent bonds. Why am I calling it as a normal covalent bond? Because in a normal covalent bond, one electron is being contributed by nitrogen and the another electron is being contributed by hydrogen. So both of them are contributing their
Can
individual
any
electron.
other atom except hydrogen be the electron deficient element?
Yeah, yeah, lot of them. Listen to me now. So this H does what? This H, the red H plus, it is gaining that cross electron from hydrogen. Are you understanding?
Yes.
And because it is gaining that one extra electron from hydrogen, what would mean? You tell me. Nitrogen is left with just one electron here.
Yes.
1 second. So what would that mean? Tell me. So hydrogen will gain that particular electron. And now because hydrogen has gained that one particular electron, what is happening? H plus is neutralized. And because nitrogen has donated one electron, because nitrogen was electron rich, so nitrogen has acquired a plus charge.
Yes.
And hydrogen has acquired a the cross electron. So hydrogen has become neutral.
And why does the hydrogen still hang around the nitrogen if the
Hmm.
electron is if it's neutral?
Because it has to still complete its duplet. It wants to complete its valence shell. That's the only purpose.
Ah.
So
So
thereby,
now
it says that,
I
nitrogen has
want
one.
more than it says that there's one more electron there and it wants to stay there.
Yes. And thereby, this hydrogen forms a bond with the nitrogen's individual left electron. But what is the difference? So now this sharing is like a covalent bond.
Yes.
But the
Ah,
transfer
so
was,
that's why they say once formed. Because that the
Hmm.
bond with the second electron is covalent.
Yes. But first
And the bond
transfer
with
of
the first
electrons is like an
electron
ionic
is
bond. Yeah. The
yes.
first transfer is like an ionic bond. The first transfer of this cross electron to hydrogen plus is like the transfer of electrons that takes place in the ionic bond.
Yes.
You understand my point?
Yes.
So as a
It's
result,
ionic and they're covalent.
it is ionic as well as covalent, correct? But that is why we call it as what? Semi-ionic bond. But you see the difference here. Both the electrons that H has and the dot electron, both these electrons were actually belonging to nitrogen. But
Yes.
during sharing, it seems that hydrogen is bringing its own electron and nitrogen is bringing its another electron. So this sharing of electrons is called as a coordinate bond. So here the coordinate bond, means that only one atom is bringing both the electrons in the sharing, and H plus is just coordinating and becoming just a part of the bond, though none of the electrons are being brought about by hydrogen. You
Yes.
understand? So NH3, these were the three original bonds, and I would draw it like an arrow towards H, and I will show that N thereby acquires a positive charge because H has gained one electron, so H has become neutral, but N has donated, so N has become positively charged. Are you understanding?
Yes.
So this is the coordinate bond. Are you understanding my point?
Yes.
So now you understand. Now the question that is asked from you now, from the bonds concept, they will say that what kinds of bond, what kind of bonds do we get or do we find in what kind of bonds do we find in ammonium radical or ammonium polyatomic ion? That's my question. Tell me. So you will say that I will have three covalent bonds, three pure covalent bonds, and one coordinate bond. Yes or no?
Yes.
So this is how the questions are actually put up. Understood or not? Right? Did you understand the concept? Hmm?
Yes.
Now have a look another question. When we look at the ozone molecule, ozone, see now what is happening? You see, O O's atomic number is 8. First thing, it is lying between 1 to 10 atomic numbers. Configuration is 2 6. So we have 1, 2, 3, 4, 5, 6. Yes or no?
Yes.
So if I have another red oxygen and we have 1, 2, 3, 4, 5, 6, because oxygen's atomic number is 8. So configuration is 2 6. Yes or no?
Yes.
So it is going to have 2 6. So there is this another red oxygen. So we will have 1, 2, 3, 4, 5, 6. So this red oxygen shall form a bond with a black oxygen and it shall be a double covalent bond. Why double covalent bond? Because one red electron, one black electron, a single covalent bond, another black electron and another red electron. You understand? And it shall be a
Yes.
another covalent bond. So two covalent bonds, thereby double covalent bond. But the O3 structure, the ozone structure, the ozone structure. What do you think you would do in this? Tell me. The ozone structure. What is going to happen
There
in
will
this
be
ozone
one
structure?
oxygen
Yes,
that has three bonds and a positive charge, and there'll be one oxygen which has only one bond and a negative charge.
exactly. So how is, just have a count of the number of electrons in the black oxygen? One, two, right? Three, four,
Yes.
5, 6. And the red ones also, it is considering its own electrons. So 1, 2, 3, 4, 5, 6, 7, 8. We have 8 electrons here in the oxygen. And when we are talking about the red oxygen, what is going to happen? You tell me. 1, 2,
It also
3,
has
4,
eight
5, 6, 7,
electrons.
8. 8. So both these oxygens are capable of completing their octets, isn't it?
Yeah, but if a
But if
third oxygen
the third
comes,
oxygen, the, let's suppose the blue oxygen that comes in here, it also has its 1, 2, 3, 4, 5, 6. And if this oxygen would also be forming bond with the black oxygen, the situation would be something like this. The
it will
situation would
put
look
a
something
single
like this.
bond.
It would look something like this. Like this. So the blue oxygen would thereby do what? The blue oxygen would also be completing its octet. The blue oxygen would also
Yes.
be completing its octet. But just have a look at the black oxygen now. The black oxygen will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
It will have 10 electrons.
So oxygen cannot have 10 electrons in its valence shell because the valence shell is what? K shell and L shell, 2 and 6. So L shell at max can hold 8 electrons. Do you understand what I'm saying?
Yes.
So, and we are saying that, in the valence shell, oxygen is holding 10 electrons. How is that even possible? That is not possible at all. You know,
Isn't it a single bond with the blue one, and the black one has a positive and the blue one has a negative?
that is how it has to be. And that is a coordinate bond. So we would draw it like this. So we will say that, the blue oxygen is not, the blue oxygen is doing nothing, is contributing nothing. Because if it does so, it would complete its own octet, but the black oxygen would thereby acquire 8, 10 electrons, more than 8. So how is this bond formed? So black one will donate its one electron to the blue oxygen. So the situation would look something like this: 1, 2, 3, 4, 5, and 6 with the blue one. So blue oxygen has 6 electrons in the valence shell of its own and one black electron coming from the black oxygen. The red oxygen is actually sharing its 2 electrons. So the red oxygen and the black oxygen, they are forming a simple covalent bond, a normal double covalent bond. But here it is going to be the oxygen is gaining one, so it requires a negative charge. And since the black oxygen has donated, so the black oxygen acquires a positive charge. And this is how this covalent bond is actually being formed now. You understand?
I'm wondering why they don't form three single bonds.
Yeah, that is a reason behind that. I'll come to that. There is a reason. But do you understand up to this point? So
Yes.
what is the scenario? The scenario is that it is going to be formed like this: O double bond O with a black oxygen and a
And then
coordinate
there will
bond
be a
O
single
towards
bond.
this now. Yeah.
Oh,
So now you tell me, how many bonds do you see in the ozone molecule? A double
three.
covalent bond? Yes.
And the single. And a
One
coordinate.
coordinate bond. Yes. You understand?
But I saw in a book that the black oxygen should have a positive one charge.
Obviously, because it
And
is
that one.
donating and the blue oxygen
Oh,
is gaining. मेडिसिन आई हैं मेरी हाँ उसका पेमेंट कर दिया वो कह रहे पेमेंट हो चुका अच्छा ठीक है ये मेरी मेडिसिन है ना ये खोल के देख लो एक बार is it clear this part so O is
yes.
donating and the blue one is gaining that is why O is getting positive charge and O is getting negative charge understood or
Yes.
not that is the concept.
Yes.
Yeah. Now have a look at the shape of this molecule. How does it exactly look? Tell me.
Bent.
Bent. So the geometry should have been what? The geometry should have been trigonal planar, but the shape is actually bent or V shape. Do you understand my point?
Yes.
That is the concept. Now, another example you see when you draw the structure of HNO3, how is the structure? See, so we say that nitrogen is there. Nitrogen is atomic number 7. Configuration is 2 5. So nitrogen has 1, 2, 3, 4, 5. So one oxygen comes here and it has 1, 2, 3, 4, 5, 6. क्या है ये मेरे नाम का है मैं 10 मिनट में क्लास खत्म करके बात करती हूँ इसको रखे रहना अच्छा ये डोरा भाई से आया है ठीक है ठीक है ठीक है राइट so it is this
Right.
1 2 3 4 5 6 so this is going to form what this is going to form a double bond
Double
right here
bond.
right and nitrogen another oxygen here see so 1 2 3 4 5 6 and we have H so one H is completing its duplet here and one oxygen is
Yes.
completing like this
And the nitrogen is having a
now
lot of electrons.
now nitrogen has completed its octet basically you see count 1 2 3 4 5 6 7 8 so nitrogen's octet is complete
But there's another oxygen
but there is another oxygen
that attacks the lone pair.
yes so now if nitrogen forms a bond with that it would be something like this 1 2 3 4 5 6 in that scenario what do you observe right here if the bond is formed something like this then this nitrogen will have 10 electrons.
So it's not possible.
It's not possible. You
You
understand?
ran out of atoms.
Exactly. So this green oxygen would do what? This green oxygen, sorry, this green oxygen would actually not share both of its electrons. So it is going to form, it is going to now beg nitrogen that, nitrogen, I want to complete its octet, my octet. But if I form a bond with you, then I don't want to trouble you as well. You will have 8, 10 electrons in your valence shell. So please do something. What will nitrogen do? Nitrogen say that, okay, I am electron rich. I am done. I am fulfilled with all my electrons. Let me do one thing for you. I will donate 1 electron to you. So this black nitrogen forming a double bond with oxygen and with the blue oxygen, it is still forming the bonds. And here with the hydrogen, this nitrogen does what? It gives 1 electron to oxygen and thereby nitrogen acquires a plus charge and oxygen has 1, 2, 3, 4, 5, 6. Are you understanding?
Yes.
And then the bond is being formed. So what do you think we have? We have nitrogen, coordinate bond O, double bond O, O, and H. You understand my point?
Yes.
So this is the structure of the nitric acid that we study, HNO3. And now if I ask you to, explain what kind of bonds does it have, you will say one coordinate bond, one coordinate bond, one,
One double
one, two,
bond.
three single bonds, one, two, and three, and one double bond. If I go in much detail, so at one place you are finding a double bond, and
Yes.
wherever
And
there is
why are there three single bonds?
yeah,
And they're just
hmm. Say it.
and they're just two single bonds. Isn't that one part of the double bond?
No, no, no. Okay, you can say for now, you can say it that way. For now, you can say it that way, but there is, since I've not explained you sigma and pi bonds, so in that sense, I was talking. Anyway, you say, yeah, you say that there are two single bonds and one double bond. But two single and one double bonds are basically what? These are sort of what? These are covalent bonds.
Yes.
Understood or not?
Yes.
Understood? Any doubts in this?
No.
Right? Now understand this part now.
Oh, that's because there are three sigma bonds
Yeah. Because this
and
coordinate
two
bond is
pi
also a sort of sigma bond only. If you know a little bit about sigma bonds, do you understand how where coordinate bonds, play their role?
Yes.
Now have a look.
To
For
tag
example,
the lone pairs.
yes. So one of the compounds should have a. So how should I actually draw the structure? I should say N carries a plus charge and O thereby carries a negative charge because it is gaining the
Yes.
electron and N is donating the electron. Are you understanding?
Yes.
Have a question. Next question. If I say ammonia is reacted with BH3, BH3 is borane and NH3 is ammonia. And I have just connected them together, combined them together, and heated them together. And now I want to know what product shall be formed. Just have a look at the nature. Ammonia is NH3 and nitrogen has a lone pair. And BH3 is like this because boron is
It
atomic
has
number
no lone
5,
pair.
2, 3. It has no lone pair. Correct.
Oh, but what if the hydrogen?
So this nitrogen
Will
donates
the
its one
hydrogen bond
electron.
to both of them?
Hmm?
Will the hydrogen bond to both of them?
Where is the hydrogen coming? The lone pair of nitrogen, the two electrons are there, right? So one would be donated by nitrogen to boron. So nitrogen is acquiring plus charge, boron is acquiring one extra electron. So these three H's remain behind boron. You understand? And one nitrogen
Yes.
is having its own electron. Now they form a bond. Now they sort of form a bond.
And what is this molecule called?
So this is basically an adduct. Adduct as in like no specific reaction has occurred as of now, but they have just bonded themselves. So this is called adduct. You understand?
Yes.
So this is the basic structure. So now the question was that what changes do you see before and after the reaction? So you will say before the reaction BH3 was trigonal planar and ammonia was pyramidal.
Now they are both pyramidal.
Now they are both tetrahedral. Because if you look at BH3, it is actually forming four bonds.
Ah,
And if you look at ammonia, it is still forming four bonds. Are you understanding?
yes.
That's how the structure is. Any doubts in this?
No.
Right? So this is how we basically draw with the structure. Understood or not?
Yes.
Do you understand the concept now? So this is
Yes.
it with the coordinate bond. And this is, I have explained you all possible types of bonds that you need to know up till any level. Right? Now, as and when the questions come up, we'll discuss them. Right, Mark? Any doubts in this up till this?
No.
And what are you supposed to revise now?